Okay, so pre-calc, here's a review of sections 4.5 through 4.8, the second half of chapter 4, that you have your test on Wednesday. Alright, so in this, I have a sine and cosine graph. We're going to sketch just one period of each one. So the first one says y equals 2 minus the sine of 2 pi x over 3. Okay, so we have here a d, a number that's going to shift this up or down. This 2 means up 2. So way down here, I'm going to do it right down here. This is my graph. We're going to have to shift up 2. And that's going to be the dotted line, the midline, that your graph is going to be centered around. Okay? Now, your a value is a -1. So the amplitude is just +1, but that -1 means there's a reflection. So be aware there's a reflect. But amplitude being 1 means we go up to 3 and we go down to 1. And there's our y-axis, 1, 2, and 3. Okay? B. B is 2 pi over 3. So to find the period, we take 2 pi and divide it by b, 2 pi over 3. This is the same thing as 2 pi times 3 over 2 pi, and the 2 pi's cancel. And your period here is 3. So we're looking for a length of 3 on our x-axis. And now to find the starting and stopping points, and again I'm doing it all in green, to find the starting point, I'll use this space right here to find the starting point. We take what's inside the sine, 2 pi x over 3, and set it equal to 0, which is the original starting point, times it by 3 over 2 pi, times by 3 over 2 pi. They cancel, and your starting point is going to be at 0 still. To find the stopping point, we'll do the same thing, and let me move over here to the side. Sorry, it's going to look bad on the next. So the stopping point, 2 pi x over 3 equals 2 pi. And again, we'll multiply by the reciprocal, 3 over 2 pi, 3 over 2 pi, but the 2 pi's cancel, and you get x is 3. And there's your stopping point, 3. So then what's in the middle? 3/2. What's in the middle of that? Well, that's 3/4. What's in the middle of this? So you can add them together and divide by 2. It's 1.5 and 3.5. The middle is going to be something fourths. I believe it'll be 7/4. Let me do the math real fast. 1.5 plus 3 divided by 2. 2.25. That is going to be 9/4. Not 7/4, 9/4. So again, you can find those points how you need to. Again, it's just adding and dividing by 2. So I did 3/2 plus 3, and then I divided it by 2. That's how I got 9/4. Okay, so here's my 5 points. Sine starts on the midline, so I'll do this in orange. Starts here, and then usually goes up, but here it's going to go down because of the reflection. So down to 1, back to the midline, up to 3, back to the midline. And here is going to be your sine curve. There we go. Okay, the next one over here, a cosine graph, y equals 2/3 cosine of x over 2 minus pi over 4. Alright. Okay, so in this graph, what we're going to do is we're going to notice there's nothing being shifted up or down, no d value. So our graph will be centered at 0. My a is 2/3, that's your amplitude. So you're going to go up to 2/3 and down to -2/3. So your graph's not going very high at all. The b value is the number with the x, that's 1/2. So when I find the period, 2 pi divided by 1/2 is the same thing as 2 pi times 2, which is 4 pi. So now, my graph is extended double, 4 pi. And now it's the starting and stopping points. To find the starting point, I take x over 2 minus pi over 4 and set it equal to 0. So we add pi over 4, and then we times by 2. And that's going to be pi over 2. So I'm going to start at pi over 2. And now to find the stopping point, so let's go pi over 2 right there. And now the stopping point, okay, x over 2 minus pi over 4 equals 2 pi, the ending. We add pi over 4. Pi over 4 and 2 pi is 9 pi over 4, right? This is just 8 pi over 4. Add pi over 4, and then times 2 times 2, 9 pi over 2. And that'll be somewhere out here. So then we find the other 3 points. Halfway between 1 pi over 2 and 9 pi over 2 is 5 pi over 2. Halfway between 1 pi over 2 and 5 pi over 2 is 3 pi over 2. And then halfway between 5 pi over 2 and 9 pi over 2 is 7 pi over 2. So our 5 points are pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and 9 pi over 2. And now cosine starts up. So my first point is pi over 2. It's going to start up at 2/3, no reflection. It goes to the midline, down to negative 2/3, back up to the midline, and ends at the top. And there is your cosine curve. Very systematic. If you get the process down, there should be no troubles. Okay. Sorry about the chicken scratch writing. Hopefully my explanation was good enough. Okay, next we have a tangent curve here. Okay, so we have the equation y equals 0.1 tangent of pi x over 4 plus pi over 4. So first thing I see, there's no shifting up or down, so I'm going to put the graph over here. So 0 is the midline. This amplitude, I don't want to call it the amplitude, but this 0.1, that's going to be 2 of the y values of 2 of our main points. And that is just 0.1, that's 1/10, so I'll put it there and there. And now b is going to be pi over 4. It's the number with the x. To find the period of tangent, you take pi, which is the original period, and divide it by pi over 4. Well, that's the same thing as pi times 4 over pi. The pi's cancel, so your period here is 4. Okay, so length of 4. And now we take what's inside the tangent, pi x over 4 plus pi over 4, and find our starting and stopping asymptotes. Pi x over 4 plus pi over 4 equals negative pi over 2. And we subtract pi over 4. When you subtract pi over 4, this is negative 2 pi over 4. So negative 2 pi over 4 minus pi over 4 is negative 3 pi over 4. And then we times by 4 over pi, times by 4 over pi, and we get negative 3. And that's a pretty nice number. I like when the pi's go away. Okay, so that'll be here. Let's go 1, 2, negative 3. And now the stopping asymptote, we take the same thing, pi x over 4 plus pi over 4, set it equal to positive pi over 2, because that's the ending asymptote. Again, subtract pi over 4. So now we have 4. Sorry. So now we have 2 pi over 4 minus pi over 4. So that's just pi over 4. And then we times by 4 over pi, times by 4 over pi. X equals, they cancel and give you 1. So now the asymptotes happen at those numbers. And then we need the 3 points in between. Well, negative 1 is right in the middle. 0 is between negative 1 and 1, and negative 2 is in between negative 1 and negative 3. Again, it's just the half points. And now right in the middle, we stay at the midline. And then if there's no reflection, which there is none, to the right you go up to that high value, to the left you go down to that low value. And it's an S-curve here and there. And there's a tangent graph. So again, just a process. Remember the differences between the sine, cosine, and tangent, your period. 2 pi for sine and cosine, pi for tangent. And when you're finding your starting and stopping points, cosine and sine is 0 and 2 pi, and they are points. Tangent is negative pi over 2 and pi over 2, and they are asymptotes. All right, next, a couple inverse problems. Here we go. Find this exact value, arc sine of the sine of 3 pi. So again, remember I was trying to talk to you about this 3 pi. Eventually, we're going to plug something into the arc sine. This sine of 3 pi will give you a sine value. You'll plug a sine value into the arc sine, so your output is going to be an angle. So what is the range of arc sine? Well, the range of arc sine is between negative pi over 2 and pi over 2. 3 pi does not belong. Therefore, your answer will not be, remember, your answer will not be 3 pi. So we need to find the answer by just doing the problem. So what is the sine of 3 pi? Well, on our unit circle, right, where is 3 pi? Well, here's pi, here's 2 pi, there's 3 pi. 3 pi is over here, where the coordinates are negative 1 and 0, cosine, sine. So what is the sine of 3 pi? The sine of 3 pi is 0. So now that value gets plugged into the arc sine. What is the arc sine of 0? Not theta. What is the arc sine of 0? Well, the arc sine of 0 between negative pi over 2 and pi over 2, which is fourth and first quadrant. That's this part. I'll do it in orange. That's this part of the unit circle. Where is the sine 0? Well, that's here at this point, where you have the coordinates 1, 0. And what is the angle between negative pi over 2 and pi over 2 that has this as its coordinates? The angle 0. So what is the arc sine of 0? It's 0. So the arc sine of the sine of 3 pi is 0. Just got to think through it. Again, if this stuff confused you, I would suggest you just do the problem. What is the sine of 3 pi? And then plug it into the arc sine. Remember, you got to know these guys. These are important, though. Make sure you know the ranges, right? The angles that these inverse trig functions work for. Okay. All right, next one. This says, and I'll write it down. It says secant arc tangent of negative 3/5. So the first thing I would do is I would suggest that this is an angle, right? It can belong to the interval negative pi over 2 to pi over 2, which is fourth and first. Since this is a negative tangent value, we are a fourth quadrant angle. And that's all I need this for. I need this to know where to position my triangle. And I'm going to position it in the fourth quadrant. So there's theta, fourth quadrant angle. Now tangent is opposite over adjacent. So on this picture, the opposite side is 3, the adjacent side is 5. And to find secant, I need the hypotenuse. So let's call it r. I need to find r using Pythagorean theorem. 3 squared plus 5 squared is r squared. 3 squared is 9, 5 squared is 25. That's 34. So r is the square root of 34. So now I want to find the secant. Now in the fourth quadrant, secant will be positive. So my answer is going to be positive. Okay? But before I find secant, let's just find cosine. So cosine is going to be adjacent 5 over hypotenuse, the square root of 34. Well, the secant is the reciprocal. Square root of 34 over 5. And that does not need rationalized. That is my answer. Square root of 34 all over 5. So use that inside inverse function to draw the triangle, and then just proceed with Pythagorean theorem to find the outside function. Alright, here we go. Before I even start out, I will say I'll do my best to draw this picture. A ship leaves port at noon with a bearing of south 29 degrees west. The ship sails at 20 knots. How many nautical miles south and how many nautical miles west will the ship be by 6 p.m.? Okay. So a ship leaves port heading south 29 degrees west. So here is my port. There are my crosshairs. South, west. South, 29 degrees west. There's my ship. Here is noon, 12 o'clock. Here's 6 p.m. Okay? So if it's traveling 20 knots, oh, sorry. So this is 29 degrees right here. And if it's traveling 20 knots for 6 hours, rate times time equals distance. 20 times 6 is 120, and that's nautical miles. So this distance is 120 nautical miles. And the question is, how far south and west will the ship be? Well, just create your triangle. Okay, I'm going to do it here in orange. If I just extend my south and I then connect this, there's a right triangle. And here is how I can find my distance south and distance west. So if you want to call this S for south and this W for west, 29 degrees is the angle I have to work with. I know my hypotenuse is 120. We can use sine and cosine. So I'm going to do it right here. So to find, let's go south. I'm going to use cosine. Cosine of 29 degrees equals my adjacent, my distance south, over 120. And when I times both sides by 120, make sure you're in degree mode, 120 cosine of 29, that's 105.0, and that's nautical miles. So this is part A. And then to find the distance west, so that's nautical miles south. And then to find the distance west, I'm going to use sine because it's the opposite. Sine of 29 degrees equals the opposite W over the hypotenuse of 120. And when I multiply 120, sine of 29 degrees, 58.2. And that's nautical miles west. So there's your question A. Okay. All right, now B. What does B say? Okay. At 6 o'clock, the ship, so here at 6, the ship changes course and heads due west. There we go. For an hour, right? 7 o'clock. So the question is, find the ship's bearing and distance from port. Okay? From port. So if I connect where he ended, this angle is my theta, right? Goes all the way across, and this is my distance from port D. Well, what was this distance? Well, I was traveling 20 knots, and that's 1 hour. This is 20 nautical miles. So remember, you need X and you need Y. Well, I have X, right? My distance west was 58. I add 20 to it. This is 78.2 nautical miles. And my distance Y is exactly what I found, 105.0 nautical miles. And now I can find theta and D using inverse trig and the Pythagorean theorem. I'll do it right here. So tangent of theta is the opposite, which is my X, over my adjacent Y. So this is going to be opposite, 78.2 over 105, and I will apply the inverse. And when I do inverse tangent of 78.2 divided by 105, I get 36.7. And that is exactly the angle that I want, because that's this theta that's coming off of south going west. South, 36.7 degrees west. Remember, sometimes it's not that easy. You have to then fix it. Remember, I want north or south first and then east or west second. Okay? And now to find the distance, I'm going to do it up above. Hopefully you have space. You're not being blocked by that. But to find the distance D, I'm going to take x squared plus y squared. So distance squared equals 78.2 squared plus 105.0 squared, and then take the square root of that. So as you do that in the calculator, I don't care how you do it, 78.2 squared plus 105 squared, 78.2 squared plus 105 squared equals like 17,000 something. Take the square root of that, and I got 130.9. And that would be nautical miles. Okay. Yeah. Okay. So there you go. So there's the distance and the angle or bearing from the part of departure. A long problem, but as long as you are organized, it's not very difficult. Okay. Got to have the right triangle. There you go, last problem. An observer in a lighthouse 350 feet above sea level observes two ships directly offshore. The angles of depression to the ships are 4 degrees and 6.5 degrees. How far apart are the ships? Okay, so here is my lighthouse, right? It is 350 feet above sea level, so that's this height. Now from here I see two ships. So from here I see two angles of depression. So remember, angle of depression, horizontal. There's an angle of depression to one ship. Now this is going to be the more severe angle, or the bigger angle. So this is 6.5 degrees. And then you have an angle of depression, I'll use different color, going out to the second ship. And that's going to be a lot smaller. Or smaller, not a lot smaller, 4 degrees. And the question is, what is the distance between the two ships? Call this distance x. Okay. Alright. Well, this is an indirect measure question. You can't find x directly because x is not part of a right triangle. I hope you do see the right triangle down here. Right? So in blue, I have in blue, I have this shorter right triangle, and in orange, I have this larger right triangle. Now, the important thing to know, angle of depression equals the angle of elevation. So if this is 6.5, so is that. And from here, I can call this y. And if this is 4, call this 4. And from here, I can let's call this z. And now to find x, I'll simply take z minus y. And that's the setup of the problem. Okay? Now notice we do not care about these line of sights. These line of sights are the hypotenuses. We don't care. So it's tangent. So let's find y first. Tangent of 6.5 degrees equals the opposite 350 over the adjacent y. Now this takes some work. So times y tangent of 6.5 degrees equals 350. Divide by the tangent of 6.5 degrees. And 350 divided by the tangent of 6.5 gives you 3071.9. And let's say that's feet. Okay. And now to find z, and I'll do it in orange, we're going to do a similar thing. Tangent of 4 degrees equals 350 over z. And you see what ended up happening here. You take 350 and divide by the tangent. Same thing's going to happen here. So z is going to be 350 divided by the tangent of 4 degrees. 350 divided by the tangent of 4 degrees. I got 5005.2. And that's feet. So then to find x, we just take those two numbers and subtract. 5005.2 minus 3071.9. And I get a number of 5005.2 minus 3071.9. 1933.3. 1033.3. And that's feet. And that's how far these two ships are apart. Okay? So again, the picture is very important. And in this case, it's an indirect measure. We have to find two measurements and then subtract them. Only because we need right triangles. Okay? I hope this video helps, and we'll see you on Wednesday. Alright, happy studying.